Welcome back to our channel. In today's video, as promised, we look at part B and C of question 4 from chemistry paper 2 for the year 2024. Question 4 had tested the understanding of the topic electrochemistry. We had done part 1 in our previous video, and those of us who did not have a chance to look at that video, kindly check it out here. So then we proceed to part B. Table 3 shows colors of aqueous ions. So we have ions in the first column and color on the second one. So we are told manganese 2 ions are almost colorless. Manganese 7 ions are purple, and nickel 2 ions are green. So the examiner expected candidates to state the observations that would be made when a nickel rod is left standing in a beaker that contains aqueous potassium manganate 7. They were to go ahead to explain the observations for 2 marks. So one thing that we take note of is that the potassium manganate 7 would actually oxidize our nickel rod to nickel 2 ions. So the expected observation here would have been that color of the solution that we are using. Remember, this is a solution that is containing aqueous potassium manganate 7. So color of the solution would change from purple to green. For the marking, we shall award half for the color purple and half for the final color green. Now, most candidates were thinking in terms of reduction of manganate 7 ions to manganese 2, and therefore they would go for the observation that color would change from purple to colorless. But please take note, this is a redox reaction. As we reduce manganate 7 ions to manganese 2, at the same time, we are also oxidizing nickel to nickel 2 ions. And as per our table, nickel 2 is color green, not colorless. So that, as we explain, we would therefore say that manganate 7 ions, you did not need to tell us the color. You only needed to have told us that manganate 7 ions are reduced. They are reduced to manganese 2. Okay? Then at the same time, nickel rod is oxidized to nickel 2 ions. So this would be the explanation for the next 1 mark. Reduction of manganate 7 to manganese 2, half a mark, and oxidation of nickel to nickel 2 ions, another half a mark. And now to part C. In part C, we are told that one of the uses of electrolysis is electroplating. So the examiner expected us to state one other use. Now, electrolysis has so many uses. Let's go ahead and list them here. One, we use electrolysis in the extraction of, and I want our candidates to be very, very careful here. We don't use electrolysis to extract all metals. We only use it to extract those that are reactive. So we say extraction of reactive or some metals. Kindly, those who were able to write that electrolysis is used in the extraction of metals, get to know you are not correct. Now, apart from writing this way, we can actually go for the particular metals. There is sodium, there is aluminum, and potassium. So you can list them as well for that 1 mark. Other than extraction of some metals, we also use electrolysis in purification of metals. Here, somebody can give an example of copper. So you can say purification of copper. We also have using electrolysis in the synthesis of chemicals. And here, a candidate could also go particular by mentioning these chemicals. We have sodium hydroxide, we have chlorine, and we also have hydrogen. Those that we get from the 3 cells that we discussed, the mercury cell, the diaphragm cell, and the membrane cell. We can also use electrolysis in anodizing of aluminium. For those who may not be able to understand the meaning of anodizing aluminium, we also want to refer you to a short that we made particularly to explain these, and therefore kindly check it out here for more information. To part C, Roman 2, silver is used to electroplate metals such as iron. We were expected to state 2 properties of silver that make it suitable for this application. Number 1, silver is attractive, which can be replaced with shiny or beautiful. Number 2, silver reacts slowly, which can be replaced by does not corrode. So any one of those would give, actually we've been asked to state 2 properties, and those ones would do. Let's end this part 2 of our video on question number 4 that tested electrochemistry in the year 2024 by having a look at part C, Roman 3. In part C, Roman 3, we were given a figure here which shows a setup for an electrolytic cell that we used to electroplate iron rod using silver. So here we are. I want candidates to take note of the cell here. The long, thin line here normally represents the positive terminal of the battery, and the short one represents the negative terminal. So it means this electrode here is the cathode. It is connected to the negative terminal, and the other one here is the anode. The next piece of information that candidates should know is that at anode, we usually have erosion. This electrode here normally erodes. It is oxidized and goes into solution in form of ions. At cathode, this is where we have deposition. So with that piece of information, I want us to take note that the iron rod here would therefore be placed at the cathode so that we're able to deposit silver on it. The anode would be made of silver metal that would erode, would actually be oxidized to silver ions. And our electrolyte here would be a solution that contains silver ions. So the examiner went ahead now to finally ask us to identify R, the electrolyte, T, the cathode, and U, our anode. And as we have rightfully discussed, R becomes our electrolyte that has silver ions. We can go for any silver salt that is soluble. So silver nitrate will do, but writing silver ions would be good enough for 1 mark. T is the cathode, and we've agreed this is where we shall place our iron rod. You can use symbols for the iron. And lastly, U is our anode. That would be your silver electrode. You can use symbols for it as well. And on that note, we've come to the end of our short video where we have looked at section B and C of question 4 that tested electrochemistry in the year 2024 at chemistry paper 2. Keep it the Kenyan teacher for more of such insightful reviews.